guys, so back to our math assignment. We're working on lesson 7, page 417 we started. So I needed to find the cost of the shirt and subtract the discount, and it tells me the final cost, right? Same thing, jacket. Here's the cost of the jacket, here's the discount, here's the final cost. Cost of the pants, here's the discount, here's the final cost. My question is, how much will he pay? Right, I know how much a shirt costs, so I need to find the discount to find out how much he's going to pay. So I know that they found these problems. They took this number times a percentage to get this number. I'm going to tell you guys it's 0.10%, right? Or 0.10, it's 10% that they are finding out. The discount is 10%. So that's what we already did. So here, and I just found the pattern here, right? 68.8, $6.88 off. 62.30 is $6.23 off. 48.50 is $4.85 off. So 34.70 is $3.47 off. I subtracted the amount of the shirt, $34.70. I took the amount of the shirt and I subtracted the discounts, $3.47. So I got $31.23. So Hank will receive a $3.47 discount on his shirt. I need to find the amount Hank will pay for the shirt, right? I found the discount just by looking at patterns, and I knew a little math there. And now I need to find out, how do I find the final cost? So if the cost of the shirt is $34.70 and he got a discount, they took off $3.47, I subtract. So I multiplied the cost of the item by 10% to find the discount. Then I subtracted the cost to find, then I subtract the discount from the cost to find the final cost. So $34.70 times 10%, which would be the same as times 0.10, is $3.47. So the discount is $3.47. The discount is how much I take off of the total price. So $34.70 minus my $3.47 discount equals, I already did the math right here, $31.23. Hank will pay $31.23 for his shirt. Does my answer make sense, right? There's a lot of different ways I could do this. I could do an estimate. I could say $34.70 is about $35. And $3.47 is about $3.50. And I could subtract there. And I would say I'll do my math. So when I have $35, I need to put my zeros there. I need to annex zeros off to my $35 so that I can subtract. Because in subtraction, I line up the decimal points. Or in addition, I line them up to do decimal places. In multiplication and division, it's different. 0 take away 0, 0 take away 0, 0. 10 take away 5. Because I borrow from here, I make this a 4. Now this is 10, 50 cents. Bring down my decimal place. 4 take away 3 is 1, and 3 bring down my $31.50. And is that close? It's about $31.23. Sorry, this wasn't my best explanation of it because I just used information I already had. But to keep going, Adrian did 13 sit-ups the first day, 20 sit-ups the second day, and 27 sit-ups the third day. So she's doing 3 days of sit-ups. If the pattern continues, how many sit-ups will she do on the 6th day? So what facts do I understand? I know first day, second day, and third day sit-ups. So first day, 13 sit-ups. Second day, 20 sit-ups. Third day, 27 sit-ups. Right? I don't know the fourth day. I don't know the fifth day. I don't know the sixth day. What do I need to find? The sixth day. So I need to know how many push-ups can Adrian do on day 6? Here's my plan. I'm going to make a chart. I like charts and look for a pattern. Alright, here's my chart and my pattern. I need 6 days, right? So I want to put a title. So I want 7 lines. So to do 7 lines, I'm going to draw 6. Or to draw 7 spaces, I'll draw 6 lines. 1, 2, 3, 4, 5, 6. And you'll see I should have 7 spots. 1, 2, 3, 4, 5, 6, 7. I'm going to divide this up into day and number. Hopefully you know that this means number. It also means pound, hashtag, but it doesn't mean number of push-ups. I can't really fit it in my box. Could have put PU for push-ups. All right, so day 1, 2, 3, 4, 5, 6. This is what I'm looking for, day 6, right? That's going to be my answer. Day 1, 13. Day 2, 20. Day 3, 27. Day 4, 5, I don't know. But I'm going to look for a pattern right here. So if you already see the pattern, this 20 with the 7 is a good hint of a pattern. They added 7. Let's see here. 13 plus 7, 20. Yes. Let's just keep adding 7 then. It looks like that's the pattern, right? This plus 7 is 20, and this plus 7 is 27, and 27 plus 7 is 34, and 34 plus 7, 41, and 41 plus 7, 48. I always get scared when I record it if I make a mess, or if I messed up. So here, double check, but it looks good to me. So 6. My answer is going to be 48 push-ups. I don't know where to write my answer. They tell me where to check it. So I'll just write it right here. Day 6 equals 48 push-ups for Adrian. I'm going to double check my answer though. Let's see. How about if I do 13 plus 7 plus 7 plus 7 plus 7 this way to do my answer. I'm going to do day 1, day 2, day 3, day 4, day 5, day 6. So 13 plus 7, 20, 27, 34, 34 plus 7, 41 plus 7, 48. And I check my answer like that. Alright, if you need to pause it, pause it. I just don't want the video to go super long because then it won't let me post it. Every year, Victoria receives $30 for her birthday, plus $2 for the year of her age. For each year of her age. Lacey receives $20 for her birthday and $4 for each year of her age. In 2013, Victoria is 10 and Lacey is 6 and 6. In what year will they both receive the same amount of money? So I have to do a little chart here, right? And these problems look so tricky and hard. Okay, sorry, my phone is ringing, so I had to check. It's the teachers, but I'm going to finish this before I get back to them. So here is our problem. So every year Victoria receives $30 for her birthday plus $2 for the year of her age. Lacey receives $20 for her birthday and $4 for the year of her age. For each year of her age. So both of these are getting, for each year of their age, they're getting $2. So at age 1, $2, age 2, $4, age 3, $6. This one's getting $4, then $8, then $12, right? Every year she gets another $4. So in 2013, Victoria is 10 and Lacey is 6. In what year will they both receive the same amount of money? So I'm going to need to make a chart here. So I'm going to do it right over here. For sure, I look at this problem, I'm like, I need a chart. So I'm going to do Victoria and Lacey. How should we do this? Let's do Victoria and Lacey. And I better put their age. So I'm going to put age over here. Or actually, I'll put year. We'll put what year they are right here. So this is in 2013. So I have to figure out when they're going to get their same amount of money. So Victoria gets 30 plus, she's 10, so she gets $2 every year. She's going to get 2 times 10 plus 20. Lacey's going to get 20, but she's only 6. But she gets 6 times 4. So plus 24. I guess I should keep track here. Let's say, I don't know where to write it. I'll just write it right here. Victoria is 10 and Lacey is 6. So I can keep track. All right, let's see. Sorry, there's a fly flying all around me. 2014. Let's see. So she gets $50 and she gets $44. Not the same, right? I could write it somewhere over here, make my chart bigger. Equals 50 equals 44. I'll write it better on the next one. All right, in year 2014, that means Victoria is now 11 and Lacey is 7. So she's going to get 30 plus 2 times 11 is 22. And she's going to get 20, right? She always gets 20. Plus 7 times 4 is 28. So she's going to get $48 and she's going to get $52. All right, I'm going to go the next year. Right, this kind of stuff, I probably wouldn't normally do it like this. I'd probably find another little pattern or way to do it because I don't know how far I'm going to be going. But since it's 5th grade math, I think we're going to stop pretty soon here. Let's see if we stop this time. So Victoria gets 30. Oh, but Victoria is now 12. And Lacey is now 8. So like she gets her 30 plus she's going to get 2 times 12, which is 24. So she's going to get $54. Lacey, on the other hand, is going to get her 20 plus she's going to get 8 times 4, which is 32. So now she's going to get $52 this year for her birthday. All right, let's try 2016. Victoria is 13. Lacey is 9. All right. In 2016, Victoria is going to get 30 plus 2 times 13, which is 26, which is equal to $56. Lacey, when she's 9, she's going to get 20 plus 4 times 9. So 4 times 9 is 36. 20 plus 36 is $56. Oh, they get the same amount, right? That's what I was finding. So in 2016, in what year will they both receive the same amount of money? In 2016, right? For a complete sentence, like I should always do. They will both receive $56. All right, and there's my problem, right? Some of these problems are hard to figure out and try to work out. I didn't have to, this is not the right way to do a chart. It's not the wrong way either. It's just a different way. I probably could have made a way better chart. I bet if we were in class, you guys would have helped me make a way easier chart to understand. But it worked. So here's Trent. He lifts weights 7 days a week. He spends 18 minutes lifting weights on Monday, 29 minutes on Tuesday, 49 minutes on Wednesday, and 51 minutes on Thursday. If this pattern continues, how many minutes will Trent lift weights on Saturday? So I'm going to try and do my pattern right here underneath. 7 days a week. So here's my pattern. 18 on Monday, 29 on Tuesday, 40 on Wednesday, and 51 on Thursday. So I need to figure out the pattern, right? This is day. I'll write it underneath. This is day 1, day 2, day 3, day 4, and I need to find out Saturday's day, right? We're only to Thursday. And you know, Monday, Tuesday, Wednesday, Thursday. So here's Friday, Saturday. I need to find this day, right? How many pounds is he going to lift for weights? Or sorry, minutes. How many minutes is he going to spend lifting weights on this day? It's going to be on the 6th day, right? Here's the 5th day. All right, so 18 plus something is 29, and 29 plus something is 40, and 40 plus something is 51. Here's my easy one. 40 plus 51. 40 plus something that's 51, 11. Let's double check. Is 29 plus 11 40? Yes, it is, right? 29 plus 11. This dang fly. Carry my 1. Carry my 1 wrong. Carry my 1. I have 40. How about, is 18 plus 11 29? Right? I could just double check. I already know it is, because I know 8 plus 1 is 9, 1 plus 1 is 2. I see my pattern. I'm going to add 11, add 11. So 51 plus 11 . 62, and 62 plus 11, right? I can just write my 11 right there now. I'm going to do 62 plus 11. 2 plus 1, 3. 6 plus 1, 7. So my answer is 73. So my answer is 73 minutes. And if I want to do real nice math, I'd probably say 59 minutes lifting weights. If I could spell weights right. Alright, sorry, it looks so messy to me. Alright, it probably looks messy to you too. Find the missing numbers in the table, then describe the pattern. Alright, so the other times they have not asked me for my pattern. They didn't ask me to tell me what the pattern is. Now, and they showed me this is this, but what's the pattern? And then I had to figure out the number by using the pattern. This time they want me to describe the pattern as well. I have to find the missing numbers and describe the pattern. So if I put in 5, I get back 9. When I put in 10, I get back 19. When I put in 15, I get back something, I don't know what. When I put in 20, I get back 39. When I put in something, I get 49. So I'm going to guess here a little bit. It looks to me like my pattern is here, right? 9, 19, 39, 49. I'm going to say this pattern is going to be 29. And then my next pattern, so let's see. If this one's 5, 10, 15, 20, I'm going to say this one's 25. But I still have to see the pattern. Let's see, what do they do? 5 plus 9, or 5 to 9 is plus 4. It can also be times 2, take away 1. Let's see. 10 to 19 is plus 9. 15 to 29 is plus 14, hopefully you guys can see, 15 plus 14 is 29. And 20 plus 19 is going to give me 39. And 25 plus 24 is going to give me 49. So can you see my pattern? I'm doing 5, 4, 10, 9, 15, 14, 20, 19, 25, 24. So every time, find the missing numbers. So I found my missing numbers, 29 and 25. So every time I'm adding the number plus one number less. There could be different ways to describe this problem, right? I'm adding one number less than original number, to the original number, to the number I'm putting in. So I put in 5, I'm going to add 4 to it. If I put in 10, I'm going to add 9 to it. If I put in 15, I'll add 14, 20, 19, 25, I'll add 24 to it. So if I put in 56, I'm going to add 55 to it, right? There's my pattern. They're skipping numbers here on our pattern, but it seems like I could use any number to find their pattern. All right, I got a couple more. Describe the pattern below. Then find the next 3 numbers. So can you see my number? It's 0.3, 0.03, then 0.3, then 3, then 30. I'm going to say the next number is 300. And I'm going to say the next number after that's going to be 3,000. And then the next number after that's going to be 30,000. Hopefully you can see this is getting bigger and bigger and bigger and bigger. And then I'm going to what I'm doing here is I am multiplying by 10. Every time I'm doing times 10, times 10, right? My easiest one to see is 3 times 10 is 30. But 30 times 10 is 300. Right? And I could see 0.03 times 10 is going to give me 0.3. Right? If I have 0.03 times 10, 3 times 0, 0, 0, 0, hold my place value. Now I'm going to put 3 times 1 is 3, and 1 times 0 is 0, and I have to put 2 numbers behind the decimal point. And that's my next number, right? 0.3. So, hopefully you guys can see that, sorry. Describe the pattern below, then find the next 2 numbers. I see why math is so hard. I'm going to get that fly. I see why math is so hard because I know it just looks hard, but if you keep looking at it, I think it's also kind of fun like a game. So if you see here, 7.8.4.5, 7.8.45, 7.845, same thing, right? I am multiplying by 10. I'm doing the same thing here. If you noticed, right, the decimal place is just moving over one place because I have the same number, so I know I'm multiplying by 1. But I'm moving over a place value. If it was multiplying by 1, 784.5 times 1 would be 784.5, right? Because any number times 1 is the same number. So I need an extra 0 so I can keep moving over a place value. So my next number, 7.845. Oh, sorry. And I'm getting smaller here. So I know I'm multiplying by 0.01. I had to stop and pause myself. Not times 0.01, times 0.1. Because I'm just moving over an extra percentage point. I'm doing the opposite of what I did here, right? Here my number got smaller and it's getting bigger. Here my big number is getting smaller and smaller. So I'm going to multiply, instead of by 1.10 by 10, I'm going to multiply by 1/10. So here I'm multiplying by 10. I'm going to multiply by 1/10. And 1/10 is the same as 0.10. So I'm going to write my answer first. Multiply by 0.1. Hopefully I said it right that time. 0.1. So this one's going to be 0.7845. And my next one, I have to put a 0 on. I hope that makes sense. All right, on to the back. Samuel is going to arrive at the airport on the first plane after 10 a.m. Airplanes arrive every 50 minutes, beginning at 6 a.m. When will Samuel's plane arrive? So he's going to arrive at the airport on the first plane after 10 a.m. Airplanes come every 50 minutes starting at 6 a.m. So I can make a little chart. I'm going to make my chart right here. All right, so my first plane is at 6. I separate my numbers like this, right? My next plane is at 6:50. My clock numbers I separate like that. Here's the hour, here's the minutes, right? And I don't add time the same way I do everything else. So 6:50 plus 50 minutes, right? It's not going to be 700. It looks like it might, but my 10 minutes is going to take me to 7 o'clock, and then I still have 40 minutes left, right? So I'm going to say 7:40 a.m., right? This is a.m., 6 a.m., first plane leaves. 6:50, next plane leaves. Another 50 minutes later, which is 7:40, another plane leaves, right? So time is a little different. I have 50 minutes, but it's only broken, I only count by 60s when I'm counting 1 hour. So 7:40 plus 20 minutes will make it 8 o'clock. 50, take away the 20 minutes, is going to leave me with 30. So my next plane leaves at 8:30. I keep on going. I'm going to double check my answer, make sure I'm not messing it up while I'm doing it. Okay, so 8:30. My next plane leaves 50 minutes later. So to get to 9 o'clock, I need 30 minutes. So now I'm going to have 30 plus 20. So I'm going to have 9 o'clock plus 20 more minutes. I'm trying to get to 10 o'clock. Anytime after 10 o'clock. Samuel will arrive at the airport on the first plane after 10 a.m. So my next plane time is going to be 9:20 plus 50 minutes. So I need a whole 40 minutes to get to 10 o'clock. So I'm going to say 10 and 40. 50 take away the 40 is going to give me 10. So when will Sam's plane arrive? 10 a.m. Maybe I'll write it right here so they know. Sam's plane is at 10 a.m. So on Serena's 10th birthday, her mom was 3 times Serena's age. How old will Serena and her mom be when her mom's age becomes 0.5? When her mom's age times 0.5 will equal Serena's age. So when will she be half of Serena's age? This is such a fun problem to figure out. All right, so let's do a little chart. So here I'm going to put Serena. Here's her mom. So my question is, how old will Serena and her mom be when her mom's age is half? Mom's age times half will equal Serena's age. So, right, Serena can never be older than her mom. It can't be 0.5, it can't be 5 times. It's 0.5, it's half. When is she going to be half her mom's age? So when she's 10, her mom is 30. Right, when she's 11, her mom's 31. 12, 32, 13, 33, right? Am I still at half? 12 times 2 is 24, 26, I'm still going. 14, she's going to be 34. Is this half yet? Nope. 34 times 2 is 28. So I'm just keeping on going. 15, then she's going to be 35. 15 times 2 is 30, so she's not half her age yet. 16, 36. 16 times 2 is 32. Nope. 17, she's going to be 37. 18, she's going to be 38. 18 times 2 is 36. Still not. 19, she's going to be 39. At 20, she's going to be 40. Do you see? 20 is half of 40. Right? If you want to double check, when Serena's will be 0.5 her mom's age. So let's see. Is 40 times 0.5 going to be 20? To double check my answer. So 0 times 5 is 0. 5 times 4 is 20. I put one number behind the decimal place. So how old will Serena and her mom be when her mom's age times 0.5 will equal Serena's age? So when Serena, why didn't I put a capital letter for Serena? That's her name. When Serena is 20, her mom will be 40. I'm going to put a period. That is 0.5 her mom's age. Right? There's not two moms. The age belongs to the mom, so I put an apostrophe. Mindy read 8 pages of her book the first day, 15 pages the second day, 22 pages on the third day. If the pattern continues, how many pages of her book will she read on the 6th day? So let's just do her pattern. Here's first day, second day, third day, fourth day, fifth day, sixth day. So I'm looking for a pattern. Let's see. 15 plus 7 would be 22. And 8 plus 7 is 15. So I'm going to keep on adding 7. 29. 36. And 43. So I'm just adding 7, right? That was my pattern. Added 7, add 7, add 7, add 7, add 7. So how many pages of her book will she read on day 6? 43 pages. I'm going to abbreviate pages there, PGS. Is what she read. And I could even put on day 6. A 1-mile hiking path has signs placed 240 feet. There are signs placed at the beginning and end of the mile. How many signs are there? Equal. 1 mile equals 5,280 feet. So if a sign is placed every 240 feet, how many signs will there be? So here is my pattern. All right, I'm going to just do my pattern right here. So they're going to put a sign every 240 feet, and if there are, it's for 1 mile, how many signs are there going to be? So I have to go to 5,280. It seems like a lot, but let's just make, it is going to be a lot. So I'm trying to just think of an easier way that for you guys to do it. Let's see, how about this? We'll do 240 is 1 mile. That means 2 miles is going to be 480. So can I count by 2s instead of counting by 1s? Maybe that'll go a little faster. So instead of adding 240 plus 240 plus 240 plus 240, I'm going to just 4 times 240. so 2 times 240 is 480. So 4 times 240 is the same as 48 times 480 times 2. So 480 times 2 is going to be 960. So because I have to go all the way to 4. So now instead of going 960 and keeping on adding 240, I'm going to count the 8th time, because I know 960 plus 960, right? If you don't, we could do our math over here. 960 plus 960. So I'm going to say 0 plus 0 is 0, 6 plus 6 is 12, 9 plus 9 is 18, plus 1, 1,920. Am I getting close to 5,280 feet? No. But so far I have 8 signs, right? They put one here, they put one here. Now I'm going to try and double this one and see, is it going to get me bigger than 5,280? Let's see, but that will give me 16, right? And then I don't have to keep adding. That'll give me 16 signs. And I'm going to add it right over here, because I already have my number right there. 0 plus 0 is 0. 2 plus 2 is 4. 9 plus 9 is 18. Carry your 1. 3,840. At 16 markers. All right, so now I'm going to try and find another pattern. I still have to go to 5,280. I could just keep adding, right? If I could do my calculator, just 240, how many times is it going to take me to get there? Or if you're smart too, right, I could divide, but we're still on multiplication. We haven't done division yet. So we're just going to keep doing this. So if I'm going to say 32 signs is going to be 3 times, that would be 6,000 too many. So I know 32 is too many. So I'm not going to add, sorry, these flies. This fly is killing me over here. So I am not going to double this and turn into 32 signs, right? Because I know that's going to be 6,000, and I only want to get to 5,280. How about if I add my 16 count plus my 4 count? Or we could try our 16 count plus our 8 count, right? I know 8 240s is 1,920. 16 is 3,840. So I'm going to add 16 plus 8. Sorry, I hope I'm not confusing you guys too much. So 1,920. I'm going to add it. 0 plus 0, 4 plus 2 is 6, 9 plus 8 is 17. Carry my 1, 3 plus 1 plus 1, 5,760. Too many! Right, that would be 16 times 8. But hopefully you guys see this is really, really, really close. So 16 plus 8, right, is 24. So let's just try one less sign. Instead of 24 signs, that'd be 5,760. This is 24 signs, right? Because it's 16 plus 8. Because 16 plus 8 is equal to 24. And I know this is 8 counts of 240. This is 16 counts of 240. But that's too big. My number's too big. I'm trying to get this number. So I'm going to subtract 1. Instead of having 24 of them, I'm going to have 23. Right? I have to subtract 240 because that's what I'm counting, how many times I'm adding 240 together. So 0 take away 0 is 0. 6 take away 4 is 2. 7 take away 2 is 5. 5 take away nothing is 5. So 5,520. Sorry, so 5,520 is still too big. So that's 23 of them. I'm going to take away one more and get to 22. I'm going to rewrite my number over here because I'm writing on top of my other problem here. So I'm going to say 5,520 take away 240. Right, and you guys have probably a different way to do this. 0. I'm going to borrow from my 5, turn that into a 4. 12 take away 4 is 8. 4 take away 2 is 2. Bring down my 5. 5,280. So 23. This take away one more. So this is 22 markers. So 22 signs. if you wanted to double check this, right, I would just do my division. That'd probably be the easiest way to do it. So 5,280, oops, let's do it over here. 5,280, just to make sure I have lots of room, divided by 240 markers. How many can go each place? So I'm going to say 240 times 1 times 2 would be 480, right? 2 times 0 is 0. I have to make sure I line up my numbers. I put this over here because I have 3 place values. I'm dividing into 3 place values. So I'm going to say 2 times. 2 times 0 is 0. 2 times 4 is 8. 2 times 2 is 4. I subtract. 8 take away 0 is 8. I need to borrow here, turn this into a 12. 12 took away 8 is 4. Is 48 less than 240? Yes, I can keep on going. Bring down my 0. How many times can 240 go into 48? Oh, looky there. 22. So 2 times 0 is 0. 2 times 4 is 8. And 2 times 2 is 4. So I get 0. So I'm going to say 22 signs. But the trick part of this problem is there's one at the beginning and one at the end. So if I put one at the beginning at my 0, I'm going to have to add 22 signs plus one more sign to put it at the beginning because I started at 0. So it's going to mean we need 23 signs. I hate when they do these tricky problems, but this is a tricky problem because they put one at the beginning at 0, and then I put one all the way along. So I'm going to need 23 signs. All right, sorry, I made such a mess on my math page. Jada lives in a city that has an area of 344.6 square miles. Her friend lives in a town that is 1/10 or 0.1 that size. What is the area of her friend's town? Nice, we finally have a little bit easier problem, even though it sounds really hard, right? This is her town. It's 344.6 square miles, right? When I count a mile, 5,280 feet. But I put it in a square so I can measure my property of land. So I put it in a square. All right, so I call it a square mile. Okay, so her friend lives in a town that's 1/10 or 0.1 that size. What is the area of her friend's town? So I know that I need to take her town and I'm going to multiply it. And I don't know how to prove you guys that, but I'm going to multiply it. But it's 1/10 of the size, right? If this is the ones place, tens place, this is the tenths place. So when I put it here, it's 1/10, which means it's smaller. And I'm just going to find out the percentage of the town, I just multiply it. I'm going to try and think of a better way to explain it. So let's see. I'm going to just take 344.6 times 0.1. And hopefully you guys remember that anything times 1 is the same. 6, 4, 4, 3. But it's decimal places, so now I have to put my decimal places back in. 1, 2, 1, 2. So her town is 34, right? It's smaller, and 4/6. And when I do miles squared, I do it like this. Miles with an exponent of 2. Anytime I see an exponent of 2, I know this is called squared. If I had it 3, I'd call it cubed. So even though it's a very easier problem, it just sounds really hard. Dennis has 9.5 weeks to prepare for a bike tour. If he rides 8.2 miles each week, how many miles will he ride before the bike tour? So he has 9.5 weeks to prepare for his bike tour. He's going to go 8.2 miles each week. So this is an easy straight up multiplication problem. So I'm going to do it over here. So I can do it. I'm going to do 95 times 82. Right? When I do this multiplication, I do it the same way I put my decimal places back in later. Because he's going to go 9.5 miles, or 9.5 weeks, right? He's going to train. So he won't train Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. He'll only train half of that week. But he is going to go a little more than 8 miles every day, 8.2. So I will add the decimal places back in later. First, I'm going to multiply. 5 times 2 is 10. Carry my 1. 9 times 2 is 18 plus 1, 19. I'm trying to line up my numbers nice and straight so I know where they are. I already multiplied by the numbers in the ones place, so I'm going to put a 0 there to hold its place value. Now I multiply by the numbers. I multiply both numbers by the number in the tens place. 5 times 8, 40. I carry my 4. I'll turn that 1 into a 4 so I don't get confused with it. Now I know 9 times 8, 72, plus 4, 76. I'm going to add those two numbers together. I get 0, 9, 7, 7. I can't forget to put my decimal places back. So I count. There are 2 numbers behind the decimal place in my problem. Right, there should have been 1 right here and 1 right here. That's 1, 2. So in my answer, I also put 2 numbers. 1, 2. 77.9 miles. This dude, Dennis, he rode on his bicycle to get ready for his bike tour. Oh my gosh, it's such a long video. Sorry.